All right, let me try another video solution. It's number 5 from chapter 20. It says, what is the total electrical force? And let me just read that carefully. Notice it said electrical force. The harder one when it says electric field. But this says electric force, all right? So what is the electrical force of traction between two charges? One charge is 3 coulombs and the other is a negative 6 coulombs, and they are separated by 2 meters. So maybe I'll just put plus 3 coulombs here and a negative, negative 6 coulombs here, and point out that they are separated by 2 meters. And so this is the fundamental of Coulomb's law. Coulomb's law looks a lot like the universal law of gravity, Newton's universal law of gravity. And so I guess I will begin when they say how do they say it here? Separated by 2 meters? What is the electrical force? Oh, and it says of attraction. So I guess we don't have to state that they're attracted to each other. That was the first thing I was going to say, but they give it in the problem. So, all right, we just have to find the magnitude of the force. But notice one's a positive and one's a negative. Opposite charges attract each other. So that's what I wanted to point out and say first, and they kind of already did it for me here. And so the other part of this is just a straightforward calculation between two charges. And so Coulomb's constant is the 9 times 10 to the 9th in units of newtons and meters squared and coulombs squared. Which means, of course, then if we put in our charges as coulombs, this would cancel off, and our distance in meters, this would cancel off, and we would be left with an answer of a force in newtons, as we should. All right, so I'll put in the 2 charges, the 3 coulombs, and I'm just going to put the 6 coulombs. And I know it's a negative 6, and you could put a negative 6 if you want, but just going for the magnitude of the force, I can just do magnitude of charge 1 and magnitude of charge 2. So there's kind of my justification, because they already told me they were attracting, and that's, again, had they not said that, I guess I would have pointed that out. And, of course, you could also say if you don't do the magnitude, if they're opposite, you come out with a negative. So the negative means they attract. I wouldn't interpret the negative as meaning it's the negative direction, because one of these, the negative one, as it is attracted, is in the negative direction, but the other one is in the positive direction. So that could be a little confusing. If I put in the negative and said, okay, I got a negative force, I would, maybe misinterpret that and think that, the force on each of these is the negative direction. And that's not the case. This one, the 3, is in the positive direction, and this one, the negative 6, is in the negative direction. So the negative just means they attract it. So I find it easier just to say they attract and then realize one's going to be positive and one's going to be negative, and so just calculate the absolute value. So that's kind of the approach I'm taking. All right, well, let me keep plugging this in, because then this distance is 2 meters squared, and as you can see, then the meters would be squared, and that would cancel off. So that's why we're going to get a unit of just a newton. And now it's just a matter of putting in your numbers here. So this is 9 times 10 to the 9th for Coulomb's constant. Then in the numerator, it's times 3 times 6, and then divided by 2 squared, which is a 4. And I will get a force of 4.05 times 10 to the 10th, which might seem like a huge force, and it is, but this is more of a statement that this is an enormous amount of charge, 3 coulombs and 6 coulombs. Remember, the electron itself is only 1.602 times 10 to the minus 19 coulombs. So you need a lot of electrons to just make 1 coulomb. In fact, I guess it would be the reciprocal of that. What is 1.602 times 10 to the negative 19? Take the reciprocal of that. Yeah, and you're looking at about 6 billion electrons to make 1 coulomb. So 1 coulomb is a very, very large amount of charge. So it doesn't surprise me this comes out to be an unreasonable amount of force, because this is an unreasonable amount of charge you're going to create. It's just too much. Things would get sucked together. You couldn't hold these things apart. You couldn't separate that much charge to begin with. All right. Hope that helps.